So here's what we've done. What we've done so far for inverse sine. We've only done with the inverse sine so far. We haven't talked about inverse cosine and inverse tangent. So I'm gonna start off with a review. The domain for inverse sine that we've learned is negative pi over 2, less than or equal to x, less than or equal to positive pi over 2. That is our domain for our inverse sine function.
Can you put that into degrees?
Um,
So it's easier to understand.
Negative 90 to 90. You can do it that way too. But the book we're going to do, and the way that we define these things is in radians. Okay. So the picture that goes with this is this picture here that I've been drawing all the time. Negative pi over 2 to positive pi over 2. So it's positive. Inverse sine is positive in quadrant 1. Inverse sine is negative in quadrant number 4. So we can only deal with quadrant 1 and quadrant number 4 when dealing with the inverse sine. And that's because we decided to restrict our domain so that the sine function actually does pass the horizontal line test and give us an inverse. That's what we've done so far. Cosine and tangent follow the same suit. The only difference is that cosine has a slightly different picture. All right? So I'll start by telling that the domain for the inverse cosine is 0 is less than or equal to x, less than or equal to pi. So interpret that. What two quadrants does the inverse cosine live if I have to stay always between 0 and pi? 1 and 2. Very good. Okay? So the picture that goes with the inverse cosine looks like this. 0 to pi. My angle lives somewhere in quadrant number 1 or in quadrant number 2. Cool thing about it is that in quadrant 1, inverse cosines are positive, and in quadrant number 2 is where inverse cosines are negative. So that's the picture that we're going to use for the inverse cosine, and the reason being is because the domain for the inverse cosine is between 0 and pi. The domain for the inverse sine is this one over here, negative pi over 2 less than x less than pi over 2, or negative 90 to 90, if you want to think of it that way. The really awesome, great news, you guys, is that the inverse tangent is it's the exact same as the inverse sine. Okay? So negative pi over 2 less than or equal to x less than or equal to pi over 2. Hey, just thinking. So it's the exact same picture for inverse sine. Negative pi over 2 to pi over 2. So it's either here or it's here. Quadrant 1, quadrant 4, positive in quadrant 1, negative in quadrant 4. All right, let's try this for example. Let's do inverse cosine examples. We want to do the inverse cosine of negative rad 3 over 2. Our goal is to find the exact value. Okay, so I have an inverse cosine, so that means I have to be between 0 and pi. That's the domain for inverse cosine. And now I want the inverse cosine of a negative. I have a negative exact value. So I'm going to be somewhere in quadrant number 2. So the thing that I'm looking for is what angle will give me a cosine at negative rad 3 over 2. That's what I'm looking for. So the angle that gives me a cosine of negative rad 3 over 2, everybody, is 5 pi over 6. Okay? 5 pi over 6. That's what that means. All right, the cosine inverse of negative 1/2. Well, again, okay, if I'm dealing with inverse cosine, I know I'm between 0 and pi, and I'm looking for a negative exact value, so I must be somewhere in quadrant 2. So what I want is the angle whose cosine is negative 1/2. Can you guys give it to me? What is it?
2 by 3.
Yeah, very. No, she's right. 2 pi over 3. 2 pi over 3. The angle whose cosine is negative 1/2. It's 2 pi over 3.
Oh, I saw.
Okay? That's what we're looking for. Okay, remember, you're gonna have a bite size after you do the first question because you're gonna create it yourself, right?
Oh, we do?
You guys, yeah, the very first question in your test is gonna be what we just created.
What if you mess up your
You don't want to mess it up.
Oh, we don't get a separate bite size?
No, you make
Take
it.
that away from us and give us the actual bite size.
No, no, no.
So,
No.
correction.
No.
What if someone, like,
No.
kills the whole thing?
All right, let's do C. Here's the one you want. Let's do this one. Inverse cosine of 0. So this says, right, what angle between 0 and pi where is the cosine equal to 0? Yes, Michael, nice job. Pi over 2. This point right here, this is the point 0, 1. This angle right here is a 90-degree angle, and that's where my cosine is equal to 0. So therefore, the answer is pi over 2. All right, we know that the inverse tangent, for the domain for the inverse tangent, it's the same exact thing as the domain for the inverse sine. So we're going to have a negative pi over 2 to positive pi over 2. So we're either swinging up or down. Now we want the inverse tangent of a positive square root of 3. So am I in quadrant 1 or am I in quadrant 4, you guys? I'm in quadrant number 1. Very good. So that means that I'm looking for the angle whose tangent is equal to the square root of 3. Well, at the very beginning of the lesson, we went and we figured out all the tangents, exact values for 30, 45, and 60 for quadrant number 1. Can you find the angle whose tangent is the square root of 3? Pi over 3. Nice job, you guys. This one's pi over 3. Okay? Because the tangent of pi over 3 is the square root of 3. Therefore, the tangent inverse of square root of 3 is pi over 3. Try this one. Tangent inverse of negative 1. So what are we looking for? Negative pi over 2 to positive pi over 2. We're looking for the angle. Okay, a lot of you are going to say 7 pi over 4. And I'm going to say that's not right because you want negative pi over 4. Good. Look at where this angle. Look how I drew this angle, you guys. This is a negative angle because it's clockwise. So therefore, I'm talking about a negative pi over 4. And the reason I'm talking about negative pi over 4 is because it falls between negative pi over 2 and positive pi over 2. If I went this way all the way around at 7 pi over 4, I'd be going outside the domain and then coming back in. So we need to relabel that as negative pi over 4. Yeah, Matt. On your own, give me this one. What's the inverse tangent of negative root 3 over 3? And draw the picture, because drawing the picture is how you show work. Inverse tangent of negative root 3 over 3. All right, you should have got negative pi over 6 for that one.
Why?
Last composite. Why don't you guys?
What is your definition of fun?
This is it. This is it. Composite trig functions. Friday night composite trig functions. All right, check it out. Here's the deal. What we're gonna do is we're gonna draw a picture. Okay. We're gonna start from the inside and we're gonna draw a picture. More importantly, we're gonna draw a triangle. Okay, we're gonna draw a right triangle more specifically. So, the inverse tangent, it's positive, right? I want the inverse tangent of 5/12. So that means I'm working either in quadrant number 4 or quadrant number 1. If it's positive, where am I going to be, you guys?
Whoa, why does it mean one?
Because inverse tangent's domain is between, right there. Same thing.
In one.
We're in 1. Good. So here's the deal. You're going to draw a right triangle in quadrant number 1 with the angle given. So we want this, again, you guys, this means the angle whose tangent is 5 to 12. That's what that means. So we're going to draw an angle and label the sides of the triangle according to that angle in a ratio of 5 to 12. So where does the 5 have to go, you guys?
5 goes on the opposite side.
5 goes on the opposite sides. 12 goes where?
Adjacent.
On the adjacent side. Very good. Okay, now, if I have a right triangle here, I know it doesn't look like it, but that's a right triangle. I knew where the 5 went because it's the tangent, and I knew where the 12 went, because it's in tangent, so it's opposite over the adjacent, right? So therefore, I know that this piece, it has to be a 13. Very good. Now, if you didn't know that, you could just say, well, 5 squared plus 12 squared equals, 13 squared. Hold on, Seth. So now that I have my picture of my right triangle drawn with an angle whose tangent is 5/13, all I have to do is take the cosine of the angle. And the cosine is defined to be the adjacent to the hypotenuse. So therefore, all of this stuff is equal to the adjacent, which is 12, divided by the hypotenuse, which is 13, and that's the answer. Okay, this says the cotangent of the inverse sine of -1/3. So what that really means is the cotangent of the angle whose sine is -1/3. So what quadrant are we in? Let's start here. We're in the fourth quadrant. Very good. Because inverse sine is only in quadrant 1 or 4, and if it's a negative, I'm in quadrant 4. Okay? It's that voice of like, not mad. It's the voice of like, I don't know how else to say it. I need like a different way of saying it. Yeah? All right. Tell me where the 1 goes. Tell me where the 3 goes.
-1.
Yeah. This is the opposite, -1. Good. 3 is the hypotenuse. It's always positive. So therefore, what's the leftover piece? No. X squared plus 1 squared equals 3 squared. X equals square root of 8, so 2 rad 2. Okay. So this is 2 rad 2. All right. So what do I want? I want the cotangent of the angle whose sine is -1/3. So cotangent of this angle. So therefore, that would be adjacent over opposite. So that would be 2 rad 2 divided by -1, which is a -2 rad 2. And that's your answer. So you should have drawn a quadrant number 1. You're in quadrant number 1 because tangent is your positive angle. So this has to be a 3. This has to be a 4 because it's opposite over adjacent. Therefore, the leftover piece has to be 5. You want the sine of that angle. Sine is the opposite over the hypotenuse. Therefore, all of this should be 3/5.